Swayam Prabha. Digital India. Educated India.
We are continuing with the earlier lecture where we have started the inverse Laplace transform. Please remember this thing, that if Laplace inverse of f s, this is equals to f t, then Laplace inverse of f of s minus a, this will be equals to e power a t into f t. This thing we are using in the last two examples. Basically, we have used this particular property that you check it here. So, in this example, what we did in the last one, this I am breaking it into two parts, as I told you. In the denominator, usually I should have only one factor. If I cannot make it into a factor, I should try to use that theorem, whatever just now I stated, that Laplace inverse of f s is f a, then Laplace inverse of f of s minus a will be e power a t into f of t. So, using that I am writing this as this one, where you see I am using this 4 s plus 1 by s plus 1 whole square plus 1. This I can write down s plus 1. So, it is s plus a. I am making it e power minus t, because e power minus a t was there, a is minus 1. I can write simply it as e power minus a t into 4 s by s plus 1 whole square. So, in the denominator, although I had s plus 1 whole square plus 1, because s square plus 1, this I am writing as 4 s by s square plus 1, and similarly for the rest part, that is 3 by s plus 1 whole square plus 1, using the property I can write it as this one, and from here I can obtain the desired result. Now, let us see this example, Laplace inverse of s by s plus 1 to the power 5 by 2. So, your problem is Laplace inverse of s by s plus 1 to the power 5 by 2. This I have to write down, since s plus 1 is there. So, obviously, I will try to make it as numerator s plus 1 minus 1 by s plus 1 to the power 5 by 2. This I will try to make it, so that I can break it into two parts. So, this is s plus 1 is there, and here also s plus 1 to the power 5 by 2 is there. So, if I write down this directly, what I can write down? E power minus t, because a is minus 1, Laplace inverse of this s plus 1, this thing I can write it simply s, and this will be s to the power 5 by 2. Or in other sense, using the property itself, this s plus 1 I am replacing by s, whereas since a is 1 here, so here e power minus t will come. So, that this is nothing but again e power minus t into Laplace inverse of 1 by s to the power 3 by 2 minus 1 by s to the power 5 by 2. And we know the function whose Laplace transforms are this thing. So, that this equals e power minus t into t to the power 3 by 2 minus 1 by gamma 3 by 2 you will get, and this also minus e power minus t into e to the power 5 by 2 minus 1 divided by gamma 5 by 2. And now, I have to break it, that I am showing you. This term gamma 3 by 2 I can bring it down to gamma half, gamma 5 by 2 also I can bring it to gamma half. So, that we know the value of gamma half is pi and root pi, and we can substitute it here. That let us see it here. You are getting this from here, you will obtain e power minus t into this using the property. From here I can write it into two parts. This is equals gamma half, this up to this I have done. This I can write it using e power minus t into root t by pi. I am breaking it, gamma n plus 1 is n gamma n using that property, and ultimately you will get the result as 2 by 3 into e power minus t into 3 minus 2 t by root over t by pi. So, next example is Laplace inverse of s by s plus 1 to the power 5. So, Laplace inverse of s by s plus 1 to the power 5. So, obviously again for this particular function, if you see here you have s plus 1. So, like earlier example, I will try to make it as s plus 1 minus 1 by s plus 1 to the power 5, and this equals again e to the power minus t into Laplace inverse of s minus 1 by s plus 1 will be replaced by s. So, s minus 1 by s to the power 5, and this is very simple. The next line you can directly do it. Laplace inverse of 1 by s to the power 4 minus e power minus t Laplace inverse of 1 by s to the power 5. And I know the functions whose Laplace transform is either 1 by s to the power 4 or 1 by s to the power 5. That I will just show it here. So, Laplace inverse of this we have done it. This is equals to e power minus t into this one, and this I am breaking it. For them the values are e power minus 3 into t to the power factorial t cube by factorial 3, and here for 1 by s to the power 5 the corresponding function is t power 4 by factorial 4. So, this is your required result. The next one is, suppose I know the value of a inverse Laplace transform, just like it is given, say Laplace inverse of s square minus 1 by s square plus 1 whole square is t cos t. It is given to me. I have to find out the Laplace inverse of this function 9 s square minus 1 by 9 s square plus 1 whole square. Or in other sense, if I know Laplace inverse of some function, using that Laplace inverse knowledge, how to find out the Laplace inverse of some other function. For this one, Laplace inverse of s square minus 1 by s square plus 1 whole square. This is equals, we have written as t cos t. So, that Laplace inverse of, if I replace a by a s, I am replacing a by a s. So, that Laplace inverse of s square minus 1 divided by s square plus 1 whole square. This is equals, what will happen here? Again, if you recall it, if I replace s, that means if I know Laplace transform of f t is f s, Laplace transform of f t is equals to f s, then f of a s will be what? F of a s, Laplace inverse of f of a s, this will be equals to 1 by a f of s by a, 1 by a f of s by a. So, that whenever you are getting this one, this is 1 by a I will leave, and your t will be replaced, this will be f of, this is a function. So, this will be f of t by a, t will be replaced here, t will be replaced by t by a. So, 1 by a is coming into t by a cos of t by a. So, therefore, Laplace inverse of s square minus 1 by s square plus 1 whole square is nothing but 1 by a into t by a cos of a t. If you see the example, in this example you have to find out the Laplace inverse of 9 s minus 1 by 9 s square plus 1 whole square. So, 9 s square means I have to make what? I have to make a as 3, because if I make a as 3, then it will become 9 s square and 9 s square minus 1 divided by 9 s square plus 1 whole square. So, therefore, on this example earlier one, whatever I got, that is Laplace inverse of s square minus 1 by s square plus 1 whole square. This is equals 1 by a t by a cos of t by a. Now, put a equals 3 in this. So, that you will get Laplace inverse of 9 s square plus 1 minus 1 by 9 s square plus 1 whole square, and here it becomes t by 1 by 9 into t into cos of t by 3. Therefore, from this problem Laplace inverse of this function is equals to 1 by 9 into cos t. So, as we are telling here, you are getting this and ultimately you are obtaining the result as t by 9 into cos of t by 3 by substituting a equals 3. So, in some cases by using the direct general parameter also, I can use it like here we have done it, replacing s by a s, and then by substituting a particular value of a, I am obtaining the required result. Next one is similar. If Laplace inverse of s by s square plus 1 whole square is half t into sin t, then you have to find out the Laplace inverse of 32 s by 16 s square plus 1 whole square. So, for this I know that Laplace inverse of s by s square plus 1 whole square, this is equals half t into sin t. This is known to me. Using the same property, Laplace inverse of a s by s square plus 1 whole square, this is equals to half into 1 by a, t will be replaced by t by a into sin of t by a. So, that Laplace inverse of 4 s by 16 s square plus 1, 16 s square plus 1 whole square if I make, this will be, that means a is replaced by 4. So, it will become 1 by 8 t by 4 into sin t by 4, sin t by 4. This 8 if I bring it here, I will obtain Laplace inverse of 32 x by 16 s square plus 1 whole square. This is equals 1 by 8 has gone over there. So, that it becomes t by 4 sin of t by 4. So, this completes the problem over here. I hope it is fine. So, I am getting this Laplace inverse of this, from here I am getting this. Now, substitute a equals 4. So, you will get 1 by 8 t by 4 sin t by 4, and ultimately you are obtaining your result as t by 4 into sin of t by 4. Now, next one is, if I know that the Laplace inverse of e power minus 1 by s by root s is cos of 2 root t by root pi t, then find the value of this one, that is Laplace inverse of e power minus a s by root s. So, if we start from here, Laplace inverse of e power minus 1 by s by root s, this is equals cos of 2 root t by root pi t. This is given to us. So, now here what I have to do, in the s should be replaced by which quantity, so that I can get, I have to find out, please note this one, I have to find out Laplace inverse of e power minus a by s by root over s. I have to find out this thing. That means, s should be replaced by something, s by k or whatever it may be. So, from here what I can write down, Laplace inverse of minus 1 by s k, that is, if s is replaced by s k, root over s k. In this case, what will happen? 1 by k will come over here from the property again into cos of, in the numerator there will be root over t by k divided by pi root over pi into t by k. This thing will come. Or in other sense, I can write down Laplace inverse of e power minus 1 by s k by root over s. If I take that root outside, then cos of 2 into root over t by k will come here, and this thing will become root pi t, because root k is cancelled and that will cancel with this root k. Now, if you substitute here k equals 1 by a. Now, substitute on this k equals 1 by a, because you have to find out Laplace inverse of e power minus a by s. So, if I take k equals 1 by a, then I will obtain Laplace inverse of e power minus a by s by root over s. This is equals cos of 2 into root over a t by root over pi t. So, I am getting my required result over here. So, if I go back to this, I am obtaining this, and from here I can directly write down this result. Next example we take as Laplace inverse of e power minus 4 s by s plus 4 to the power 5 by 2. So, Laplace inverse of e power 4 minus, we know, let us start from scratch here. Laplace inverse of 1 by s plus 4 to the power 5 by 2, let us start from here. This is equals, I can write down s plus 4 is there. So, minus 40 into Laplace inverse of simply s plus 4 will be replaced by s and s to the power 5 by 2. Using that property, this equals, I can write down e power minus 40 will come here, and Laplace inverse of 1 by s to the power 5 by 2, whose function, corresponding function is known to us, that is Laplace inverse we can write down very easily. E power minus 40 into t to the power, it will be 5 by 2 minus 1 by gamma 5 by 2, and this equals, you can write it, 4 will come over here. If I calculate, t to the power 3 by 2 e power minus t will come over here, divided by 3 root pi. I am getting this. So, Laplace inverse of this equals this one. Therefore, Laplace inverse of e power 4 minus 3 s by s plus 4 whole to the power 5 by 2. This will be equals to, again using property, you can write down e power 4 you are coming out, and this equals L inverse e power minus 3 s by s plus 4 to the power 5 by 2. I can write down this. And what is this? Laplace inverse of e power minus 3 s divided by s plus 4 whole to the power 5 by 2. This I can write it as a function like this, e power 4 into 4 by 3 root pi will come here, 4 by into t minus 3 to the power, it will be 1 by 2. So, it will be 3 by 2 into e power minus 4 into t minus 3, whenever t is greater than 3, and it is equals to 0 otherwise. So, using the properties, I know this thing, that this is the inverse Laplace transform of this function is this for t greater than 3. So, I am writing this, and it is 0 otherwise. So, basically it is a otherwise means I will say that for t less than 3. So, I can represent it in terms of a unit step function also. So, that always whatever way I want, I can represent the function, and inverse Laplace transform I can try to find out for this. So, this was the inverse Laplace transform was there, e power minus 40 into this. So, I am getting this, and this for this function e power minus 3 s by s plus 4 to the power 5 by 2. Using the property directly, I can write it as 4 by 3 root pi t minus 3 to the power 3 by 2 into e power minus 4 into t minus 3, and this equals as a you can write it as an unit step function, which we have written as h of t minus 3 in terms of Heaviside unit step function. Now, let us see about the derivatives of inverse Laplace transform. We have seen that if I know the Laplace transform of a function from theorem, I can tell what would be the Laplace transform of derivatives, or in particular I will say nth derivative of a function. Similarly, here also I can find out the inverse Laplace transform of derivatives, that is, if Laplace inverse f s equals f t, we know, then Laplace inverse of f n s, that is nth derivative of the Laplace transform of f s, this equals minus 1 to the power n t to the power n into f t. So, let us see how it works over here. Let us start from right side, that is t to the power n into Laplace transform of t to the power n into f t. This is equals, using the properties I know, minus 1 to the power n d n d s n of f s. Using the theorem of the derivative of Laplace transform, I can tell that Laplace transform of t to the power n into f t, this is equals minus 1 to the power n into d n d s n of f s. So, that I can write it as minus 1 to the power n, I can write down this as nothing but f n s. d n d s n means nth derivative of s. Therefore, you can say that t to the power n into f t, this is equals Laplace inverse of minus 1 to the power n into f n s. You can write down, and minus 1 to the power n I can bring outside, Laplace inverse of f n s. Therefore, what you can tell, Laplace inverse of f n s, this is equals minus 1 to the power n t to the power n into f t. Minus 1 to the power, this will be minus n, of course, this one will be minus n initially, but this equals, I can write it again, minus 1 to the power n t to the power n into f t, and this completes the proof of the theorem. So, if I go back, I had to prove that Laplace inverse of f n s equals minus 1 to the power n t to the power n into f t. So, I started with Laplace transform of t to the power n into f t equals minus 1 to the power n d n d s n of f s, because this is known from the derivatives of the theorems of Laplace transform. From here I am writing it minus 1 to the power n f n s, and then I am getting the directly the result over here, Laplace inverse of this thing, and equals minus 1 to the power n Laplace inverse of f n s, and this I can write down this way. So, the ultimately we are getting the proof of this thing. Next is inverse Laplace transform of integrals, means if Laplace inverse of f s equals f t, then Laplace inverse of s to infinity f x dx, this will be equals to f t dt. Means if you are integrating the Laplace transform f s from s to infinity, then the Laplace inverse of that function will be equals to f t by dt. Just like in the earlier case, it was if I am Laplace inverse of the nth derivative of the function is minus 1 to the power n to the power n into f t. So, for the proof of this one, we know this thing, Laplace transform of f t by t will be equals to s to infinity f x dx, provided of course, limit t approaches 0, f t by t, t approaches 0, f t by t exist. So, we know Laplace transform of f t by t equals s to infinity f x dx, provided this particular integral exists. This we have seen in the Laplace transform of the properties of Laplace transform. So, therefore, you can write down Laplace inverse of s to infinity f x dx equals f t by t. So, once I am doing this one, I got the required result over here, and if I come back to the this thing, only thing here you see I am using this theorem whatever we have done earlier. Using that theorem I am just getting this thing, and this completes my proof. Now, let me do one more thing, multiplication by power of s. If Laplace inverse of f t f s equals f t and f 0 equals 0, then Laplace inverse of s f s, if you are multiplying the function f s by s, that will become the derivative of the function, that is f dash t. So, we have the Laplace inverse of, again just we are using the properties of Laplace transform. It is equals to s f s minus f 0, and it is given that f 0 is equals to 0. So, that it becomes, this is nothing but this part is 0. So, it becomes s f s. So, that Laplace inverse of s f s, this equals, you can write down f dash t. This completes the proof of this particular theorem. So, let us stop here. In the next lecture, we will see this we have done for the multiplication. If you see, we have done it for the multiplication by power of s. Next, we will see the division by power of s also. We will see over here, and this is the proof of this example.